Our planet, Earth, is a place of constant change. Mountains rise and crumble, oceans swell and recede, and the very ground beneath our feet is in a perpetual state of transformation. Life evolves, adapting to the ever-shifting landscape, finding ways to thrive in the most unexpected places. But have you ever wondered what our world was like billions of years ago, long before the first animals took a breath or the first plants stretched towards the sun? Imagine a time when the Earth was a barren, rocky expanse devoid of the vibrant life we see today. Join me now on a journey through time as we venture back to a period when Earth was a very different place. A place where the landscapes were stark and empty and the air was thick with primordial gases. Imagine a world without continents, without oceans, and without the familiar blue sky. A world where the surface was a vast, desolate expanse waiting for the first signs of life to emerge. This is Earth, 10 billion years ago. A planet in its infancy, still forming and evolving, with no hint of the complex ecosystems that would one day flourish. This is the story of our planet's earliest days, a time when the forces of nature were at their most raw and powerful. By understanding our planet's past, we gain a deeper appreciation for the forces that have shaped our world and the remarkable journey that has led to the rich tapestry of life we see today. From the barren landscapes of ancient Earth to the diverse ecosystems that now cover its surface, our planet's history is a testament to the power of change and adaptation. 10 billion years ago, our solar system was in its infancy, a chaotic and dynamic place filled with potential. The sun, a fiery ball of gas, had only recently ignited, bathing the surrounding space in light and heat, marking the beginning of a new era. Around this young star swirled a disk of cosmic debris, gas, dust, and rocky remnants left over from the sun's formation, creating a vast, swirling protoplanetary disk. Within this swirling chaos, gravity worked its magic, pulling together clumps of matter, slowly but surely shaping the future of our solar system. Over millions of years, these clumps grew larger, colliding and coalescing in a cosmic dance of creation and destruction, until they formed planets, including our own Earth. The early Earth was a hot, molten world, bombarded by asteroids and comets, its surface a fiery, turbulent landscape. The atmosphere, if you could call it that, was a thin veil of hydrogen and helium, the lightest elements in the universe, barely clinging to the planet's surface. These gases would have been stripped away by the relentless solar wind, a stream of charged particles constantly flowing from the sun, leaving Earth exposed and vulnerable. As time went on, the Earth began to cool, volcanic activity gradually forming a more stable crust, setting the stage for the next chapter in our planet's history. Imagine a landscape utterly alien to our own. There were no oceans, no continents, only a vast, undulating sea of molten rock. Volcanoes erupted across the surface, spewing lava and gases into the primitive atmosphere. The air was thick with noxious fumes, unbreathable for life as we know it. The surface temperature soared to thousands of degrees, hot enough to melt rock. This wasn't a place for the faint of heart. Any visitor from modern Earth would have been instantly incinerated. This period of intense heat and bombardment is known as the Hadean Aeon, named after Hades, the Greek god of the underworld. It was a time of unimaginable violence, a crucible in which our planet was forged. Unlocking the secrets of Earth's earliest days is no easy feat. The planet has been constantly reshaping itself over billions of years, erasing much of the evidence of its early history. Yet, like detectives piecing together clues from a crime scene, scientists have developed ingenious methods to study this ancient past. One key piece of evidence comes from meteorites, fragments of asteroids and comets that have fallen to Earth. These celestial time capsules offer a glimpse into the composition of the early solar system, providing clues about the building blocks from which Earth was formed. By analyzing the chemical makeup of meteorites, scientists can learn about the conditions that existed in the early solar system and the processes that led to the formation of planets. Section 5, The Earth Breathes. As the early Earth cooled, a remarkable transformation began. Water vapor released from volcanic eruptions accumulated in the atmosphere, As temperatures dropped further, this vapor condensed, forming clouds and eventually raining down upon the scorching surface. The rain was relentless, falling for millennia, forming the first oceans. This marked a turning point in Earth's history. The oceans would become the cradle of life, providing a stable environment for the first organisms to emerge. The atmosphere, too, was undergoing a dramatic change. Volcanic eruptions released gases from the Earth's interior, including carbon dioxide, nitrogen, and water vapor. This mixture of gases formed a new atmosphere thicker and denser than the thin veil of hydrogen and helium that had existed before. Section 6. A world transformed. The contrast between the early Earth and our planet today is stark. Imagine standing on the shores of a primordial ocean, the air thick with volcanic gases, the sky a dull red. The only landmasses are volcanic islands poking through the water's surface. The continents we know today, vast landmasses teeming with life, were formed much later through the slow, relentless movement of tectonic plates. These plates, giant slabs of Earth's crust, constantly shift and collide, pushing up mountains and carving out ocean basins. The early Earth was a world in constant flux, shaped by forces that continue to operate today, albeit at a much slower pace. Section 7. The building blocks of life. While the early Earth was a harsh and unforgiving place, it was also a world brimming with potential. The planet's surface was constantly reshaped by volcanic eruptions and meteor impacts, creating a dynamic and ever-changing environment. The oceans, teeming with dissolved minerals and bathed in energy from the sun, provided the perfect environment for life to emerge. These vast bodies of water acted as a cradle for the first building blocks of life, where complex chemical reactions could take place. Scientists believe that the first life forms were simple, single-celled organisms that arose in these primordial oceans. These microscopic entities were the pioneers of life, setting the stage for the incredible diversity we see today. These early life forms, known as prokaryotes, were able to harness energy from their environment and reproduce, passing on their genetic information to their offspring. This ability to replicate and evolve was crucial for the development of more complex organisms. The emergence of life on Earth is one of the most profound mysteries in science. It marks the beginning of a journey that has led to the rich tapestry of life we see today, from the simplest bacteria to the most complex multicellular organisms. While we don't know exactly how life arose from non-living matter, scientists are making strides in understanding the chemical processes that may have been involved. Through experiments and simulations, researchers are piecing together the puzzle of how life's essential molecules could have formed and interacted in the early Earth's environment. Section 8. A universe of possibilities. The study of Earth's early history is not just about understanding our own planet's past, it also provides insights into the potential for life beyond Earth. By studying the conditions that led to the emergence of life on our own planet, scientists can narrow down the search for habitable worlds elsewhere in the universe. If life could arise on a hot volcanic world like the early Earth, it raises the tantalizing possibility that life may exist on other planets and moons, even those that seem inhospitable by our standards. The search for extraterrestrial life is one of the most exciting frontiers in science, and understanding Earth's early history is crucial to this endeavor. Section 9. Reading the rocks. Geologists, like historians studying ancient texts, decipher the layers of rock to piece together Earth's past. These layers, formed over eons, hold clues to past climates, volcanic eruptions, and even the fossilized remains of ancient life. Imagine these rock layers as pages in a giant history book. Each layer represents a different chapter in Earth's story, with the oldest layers at the bottom and the youngest at the top. By studying the composition and structure of these layers, scientists can reconstruct past environments and track the evolution of life on Earth. Section 10. Rather, time before time. Our journey back to Earth 10 billion years ago has taken us to the very dawn of our planet's existence. It was a time of fire and fury, a time before continents, oceans, or life as we know it. Yet even in this alien landscape, we can see the seeds of our own existence. The same forces that shaped the early Earth, volcanism, plate tectonics, and the cycling of elements, continue to operate today, albeit at a much slower pace. By understanding our planet's past, we gain a deeper appreciation for the delicate balance of conditions that makes life on Earth possible. Section 11. Our place in the cosmos. As we conclude our journey through time, we are left with a sense of awe and wonder. The Earth beneath our feet, once a molten inferno, has transformed into a vibrant oasis teeming with life. The story of our planet is a story of constant change, of creation and destruction, of resilience and adaptation. By studying Earth's history, we gain a deeper understanding of our place in the cosmos and the preciousness of the planet we call home. Let us strive to protect and preserve our planet for future generations, so they too can marvel at the wonders of Earth's long and epic story.